This is Unit 11, Reactions, Part 1 Notes. By the end of this unit, you should be able to use the law of conservation of mass to write and balance chemical equations. You should also be able to recognize the different types of chemical reactions and be able to predict products in a chemical reaction. A chemical equation is a representation of a chemical reaction. The reactants on the left are connected by an arrow to the products on the right. This helps us to quantify changes that occurs during chemical reactions. So we use a couple of symbols to help us identify what is going on in a chemical equation. The first two here are the plus sign and the arrow, which is a yield sign. So we're going to have our reactants that are on the left, and if it's multiple reactants, we'll use a plus arrow to specify that, so it's just going to be another R. They're going to yield our products. And if we have more than one product, we'll use that plus sign to identify that there's two species on our product side. Later in the year, when we talk about acid and bases, this is our reversible reaction where the products and reactants can go back and forth, and we'll talk about the difference between a full arrow going directly to the right and one that goes back and forth. But if we use the one that goes directly to the product, that means it cannot be reversed. We'll also use states of matter within parentheses, and this is going to designate the reactant or the product as either being a solid form, liquid form, or in gaseous state. Later on, we'll see this AQ. AQ stands for an aqueous reaction, meaning it is occurring in water. The only time the L is going to be used is going to be for pure H2O liquid. So here's your AQ. This designates that it's in an aqueous solution, so the reactants will be dissolved in water, and that's going to come up later in this year. If you have addition of heat in the reaction to make it happen, we'll use a triangle arrow, and then we can specify it with heat. And then if we have to use a catalyst in the reaction to help it go, we'll specify that by writing the catalyst name above the yield sign. So all chemical equations must abide by the law of conservation of mass. This says that mass cannot be created nor destroyed. So therefore, the mass of the reactants must be equal to the mass of the products. And we balance and make sure everything is equal by using what is known as coefficients. We cannot change the subscript, because if you do, then you actually change the substance. So for example, in this aluminum oxide compound, if we change the subscripts, it turns aluminum oxide into something completely different, and that changes the entire reaction. So we use coefficients to balance the chemical reactions, and that allows the masses to be equal, because if the atoms are equal, then that means the masses are equal as well on both the reactant and the product side. And just to remind you, reactants will always yield the products. So for example, if we're looking at this ammonia with the 2 in the front and the 3 in the back, the 2 at the very beginning is going to be our coefficient. This is going to indicate the number of particles of the entire substance. So here I have 2 entire molecules of NH3. That means I have 2 entire molecules of NH3. And these are going to change to help balance the reaction. The subscripts, remember the 1 that's understood, and this 3 that's actually written here, is going to indicate the number of atoms of each element within that specific substance. So the understood 1 says we have 1 nitrogen, and then the 3 on hydrogen means that we have 3 atoms of hydrogen. And if you change the subscripts, you actually change the chemical identity of that substance, so it no longer makes that reaction the same. So total, if I were to count the total atoms in this example right here, the 2 times 1 nitrogen would mean I have 2 nitrogens, and then the 2 times the 3 hydrogens would mean that I have 6. So we use these coefficients in the front to change the number of atoms, because we always want to make the left side equal the right side. And if you look at the picture or the example where we have aluminum combining with oxygen to yield aluminum oxide, we add the numbers at the very beginning to make sure everything is equal. So if I were to determine the atoms on both sides, I know I have 4 aluminums on the left. The 2 times the 2 aluminums is 4 on the right. 3 times 2 oxygens is 6. And then the 2 times those 3 oxygens are also 6. So to balance chemical reactions, we use coefficients. And the first thing that you have to do is write all of the elements present in the chemical reaction. So I make my divider right underneath the arrow, and I write all the elements that are listed. So I have hydrogen, I have sulfurs, I have silvers or Ags, and I'm going to keep my polyatomic together, my nitrate, my NO3. And then I'm going to count and write the number of atoms of each element on the reactant side. So remember that reactants yield products. I have 2 hydrogens, I have 1 sulfur, I have 1 silver, and 1 complete nitrate, or 1 NO3. On the other side, I have 1 hydrogen, I still have 1 nitrate, I have 2 silvers, and 1 sulfur. So I did the same thing for the reactant side as I did the product side. Now I'm going to add coefficients to help balance this equation. So I'm going to first try to get my hydrogen atoms to be equal, so I'm going to add a coefficient of 2 in front of the entire product, HNO3. So now the 2 multiplies through everything, and it stops until you get to that plus sign. So 2 times 1 hydrogen is now 2, and then 2 times my nitrate gives me 2 nitrates as well. So now my hydrogens are all balanced, awesome. My sulfurs are balanced, and I need to go back and rebalance my silvers and nitrates. And what I can do is put a 2 on the other side, and now this 2 multiplies through everything. So I have 2 silvers and 2 nitrates. So now everything is equal. So my coefficients of this reaction, if you don't write anything, it's an understood number 1. So my coefficients are a 1, 2, 2, 1 for this reaction. There are 5 types of chemical reactions. The first one is known as a synthesis or a combination. This is where 2 or more reactants combine to form one new product. So this is represented by the skeleton. A plus B yields AB. So we have 2 single elements will combine to create a compound. So it's just they are combining, so hence the combination, combining to make one product. If you have a decomposition reaction, that's where you have 1 reactant will form 2 or more products, probably through the process of breaking down. So it's the opposite of your synthesis. So where you have 1 large compound or 1 large substance is breaking up into 2 or more smaller products. So you have an example of 1 compound splitting up into 2 different species. Then you have combustion reactions. This is where you have a hydrocarbon with a backbone of CH. The X and Y are just different subscripts. They're going to react with specifically oxygen, molecular oxygen with an O2. And it's only going to produce carbon dioxide and water. If you go back to the first one, the synthesis, this is the only example, or I guess only example, this is an example of where it's not combustion because you have magnesium combining with the oxygen to make magnesium oxide. If you specifically produce carbon dioxide and water, obviously they can have different coefficients to make it balanced, but only the products carbon dioxide and water can be made from the reaction of a hydrocarbon and oxygen. That is a combustion reaction. So the last 2 types of chemical reactions are a single replacement and a double replacement. In a single replacement, a more reactive, that should be IVE, a more reactive element reacts with a compound to form a different compound and a different element. So it's pretty much 1 ion or 1 element is going to replace another within that compound. So in this skeleton backbone or skeleton equation, element B is going to displace element A, so now BX can form a compound and A is now all by itself. So the easiest way to identify a single replacement is whenever you have an element plus a compound is going to yield a new compound with a new single element. So element here is the key for a single replacement. For the double replacement, you have 2 ionic compounds that are going to react to form 2 new ionic compounds. So this is a compound plus a compound reaction. So single replacement is an element plus a compound. A double replacement is when two compounds are reacting together to form two new ones. So really what's going to happen is that the A and B in the first two compounds are going to switch places. So now A is going to make a bond with Y, and B is now going to make a bond with X. So they just kind of swap partners. Okay, so I want you to press the pause button. I want you to try to balance the following reactions and identify the type of reaction. So the first one, I'm going to draw my little divider and write the elements listed. So I have sodium. I do have the ClO3 as a polyatomic, however the Cl and the O on the product side are not together, so this is a case where I cannot keep the polyatomic together. So I have Na, Cl, and O. On the reactant side, I have one Na, I have one Cl, and I have 3 oxygens. On the right side, I again have one Na, I have one Cl, but now I have 2 oxygens. Okay, so I have an issue with the 2 and the 3. Well, the lowest common denominator for 3 and 2 would be to get both of them to a 6, because if I put a coefficient in front of the reactant, now I have 6 oxygens. And then if I put a 3 in front of this oxygen, I also now have 6. But don't forget that the 2 has to travel through the entire substance. So I have 2 NAs, 2 CLs, and 6 oxygens. On the right, I have 6 oxygens, so those are balanced, but then I need to go back and rebalance my Na and my Cl. So the coefficients are a 2 to 2 to 3 ratio, and if I have one large compound breaking down into 2 or more products, this is a decomposition reaction. So I'll just write decomp for short. On the next one, I'm going to draw my divider and write the elements. So I have Pb. Ooh, I can keep my NO3s together, since they are both on the left and the right side. I have hydrogens and then I have sulfurs. Let me change the color here. Alright, so on the left side I have 1 Pb, I have 2 nitrates, I have 2 hydrogens and 1 sulfur. On the right I have 1 Pb, I have 1 S, I have 1 hydrogen and 1 NO3. So really the only thing that I have to do here is just put a coefficient of 2 in front of my HNO3 to where the 2 multiplies through everything, and then I have a total of 2 hydrogens and 2 nitrates. So everything should be balanced. 1 and 1 Pb, 2 and 2 NO3s, 2 and 2 hydrogens, and then 1 and 1 sulfur. So anything that's not written with a coefficient is an understood number 1. So this number 2 reaction, my coefficients are a 1 to 1 to 1 to 2 ratio. And I have a compound plus a compound where the Pb and the hydrogen switch places. So this is going to be a double replacement reaction. And then my last one, I have C, H's, and O's. So on the left side, I have 1 carbon, 4 hydrogens, and 2 oxygens. And then on the right, I have 1 carbon, I have 2 hydrogens, but then I have the 2 plus 1, so I have 3 oxygens. Again, our issue is the 2 and the 3 here. Well, here's the thing with combustion reactions, you always want to make the last oxygen here even, because if I don't have a coefficient, that 1 will always make something odd, because this is going to be a factor of 2. So I want to get rid of the odd oxygen by putting a coefficient just to start, and this is going to change my coefficients. Let me change the color here. So now I have 2 times 2 hydrogens, now I have 4, so those are balanced. And then those 2 oxygens plus the original 2 now gives me 4 oxygens. So then I can go back to the other side, turn the 2 into a 4 by putting a 2. So then everything is balanced. Anything I don't fill in is an understood 1. So the coefficients of this reaction are a 1 to 2 to 1 to 2. And this is signified by a hydrocarbon reacting with oxygen, specifically producing carbon dioxide and water. So this is going to be a combustion reaction. So did you accomplish the objectives of this unit? If not, please go back and rewatch the video or make marks of anything that was confusing or you want me to clarify for any of the notes or the problems for the next time we have this lecture.